This is Mrs. Frazier with part 2 of our algebra review. Number 4, Amanda was asked by her math teacher to solve an inequality on the board. Amanda put the following on the board. Did Amanda make a mistake? And if so, what did she do wrong? So looking at the problem, first I would check to see if Amanda distributed right. So negative 2 times x is negative 2x. And negative 2 times negative 1 is positive 2. So it looks like she distributed correctly and brought down her terms correctly. It also looks like the next step that Amanda took is she combined like terms. She took 3x minus 2x and got 1x. It also looks like that she subtracted 2 from both sides, which gave her negative 12 on the right side and eliminated her 2 on the left side. The next step it looks like she did is she took away 2x. When she took away 2x from both sides, so 1x minus 2x, she ended up with negative 1x is less than or equal to negative 12. And then it looks like the last step she took is divided by negative 1, which gave her a positive 12, and x is less than or equal to 12. So I see that Amanda made a mistake at the very end when she divided by a negative. Anytime you divide by a negative, it creates whatever you had to become opposite. So the negative 12 became opposite to a positive 12, but we also have to flip our inequality symbol. So the inequality symbol is no longer less than or equal to, but it should be x is greater than or equal to 12. So Amanda should have flipped the inequality symbol. Number 5, if f of x equals 2 times x minus 3 plus 4, find f of negative 8. Okay, if I want to find f of negative 8, I want to find y, or what my function equals when my input is negative 8. So I'm literally going to plug in negative 8 into my function to find out what my output will be. So negative 8 minus 3 is negative 11. Multiplying by 2, 2 times negative 11 is negative 22. So for an input of negative 8, f of x, or f of negative 8, I should say, equals negative 22. Oh, goodness. Okay. Evaluate the function f of x equals 2x squared plus 5x minus 9 for f of negative 3. So just like number 5, I'm looking for my output when my input is negative 3. So anytime I see x, I'm going to plug in negative 3. So I have 2, and I have negative 3 squared plus 5 times negative 3 minus 9. So I have to do my exponents before I multiply, because that's order of operations. So negative 3 squared is positive 9. So I have 2 times 9 plus 5 times negative 3, which is negative 15, times negative 9. So 2 times 9 is 18. Negative 9 times negative 15 is 135. And 18 plus 135 will give me 153. So f of negative 3 equals 153. Number 7, write the first 4 terms of the sequence described by the given functions. So a, f of 1 equals 12. So my first term is 12. And I want to know what my next 4 terms will be. So if my first term is 12, to find my next term, 2 minus 1, and then I'm going to add 7, right? So f2 minus 1 is f of 1 plus 7. So I'm going to take my first term and I'm going to add 7. So 12 plus 7 is 19. So my next term is 19. I can continue. I can look for my third term. So to find my third term, I'm going to do 3 minus 1, which will give me my second term. I want to add 7. So I want to take my second term and add 7. So 19 plus 7 will give me 26. And now that I know I'm just adding 7, I'm just going to continue. My third term will be 33. And my fourth term will be 40. So looking at B, if my first term is 10.5, and I can see that I'm going to take away 4, so my common difference is negative 4. My first term is 10.5. My second term, take away 4, is 6.5. My third term is 2.5. And my fourth term is negative 2.5. Number 8, write the first 4 terms of the sequence described by the given functions. So now I have my explicit formula where above I was looking at my recursive. So looking at my explicit formula, I know that the first number is my first term. And this is my common difference. So if I want the first 4 terms, I'm going to do 85 minus 2, and I want the first term, so 1 minus 1. 1 minus 1 is 0. Negative 2 times 0 is 0. And then I'll have 85, which gives me my first term, 85. I can keep plugging in, so I could go ahead and plug in 2 in place of n and do 2 minus 1. But I know that my common difference is minus 2, so I'm going to have 83, then 81, and then 79. Looking at B, my first term is negative 12, and my common difference is 2.5. I can use my function and I can plug in 1, 2, 3, and 4 to find my first 4 terms, or I can just use my common difference. So I'm going to add 2.5. So negative 12 plus 2.5. So negative 12 plus 2.5 is negative 9.5, negative 7, and negative 4.5. So again, I can plug into my formula 1, 2, 3, and then 4 and get this, or I can just use my common difference of 2.5 to find each of those values. Oops, sorry about that. So number 9, write a function for each sequence in the form of explicit, recursive, and slope-intercept form. So we're going to look at each of our sequences and write a different formula for each. So looking at A, I can see that my common difference is 4. And I can also see that my first term is 26. So my explicit formula, or let's start with my recursive formula. My recursive formula is going to be my adding the 4 each time. So I'm going to take my previous term, whatever it may be. So f of n equals my previous term, f of n minus 1. And I'm going to add 4 each time. So plus 4. My explicit formula always starts with my first term. So to find f of n, or my nth term, I'm going to take my first term, 26. I'm going to add my common difference times 1 less than my previous or the term number that I need. So if I'm looking for my third term, I know I need to add 4 2 times. If I'm looking for my fifth term, I know I need to add it 4 times. So 4 times n minus 1. So my slope-intercept looks a lot like my explicit formula. Remember, slope-intercept is y equals mx plus b. So I can write it as f of n equals, and now I have my slope, or my common difference, in this case, of 4n. And instead of adding to get to 26, well, I need to do a little bit more than that. So like say I want my first term, 4 times 1, that's 4. What do I need to add to get to 26? Well, I need to add more. I need to add less, actually, than 26. Well, 4 times 1 is 4. I need to add 22. So in this case, I'm looking for like my 0 term. So I worked backwards 1 to find that. So B, I'm looking for a common difference again, and my common difference is 15 minus 15. So D equals negative 15. My first term is 41. So starting with my recursive, I'm going to take my previous term, and I'm going to subtract 15 to get to my next term. My recursive, my explicit, I want to take my first term, 41, and add negative 15, or I really should say subtract 15 times n minus 1. And my slope-intercept form, I still have that common difference or slope, so I can have negative 15. But I'm going to work backwards 1 more to get to my 0 term for slope-intercept because I need my y-intercept. So I'm going to add 15 back to 41, and I'll have 56. So negative 15n plus 56. Okay, number 10, write the equation in terms of t, a equals p plus prt. So I want to solve for t, so I know I need to get rid of p first. So I'm going to subtract p from each side. I'll have a minus p equals prt. I need to get t by itself, so I'm going to undo that p and r by dividing on both sides. So now I have t equals a minus p over pr. Number 11, write the equation in terms of x. 2x plus a equals p. So to solve for x, I need to subtract the a away from both sides, which will leave me 2x equals p minus a. And then I need to divide both sides by 2. X equals p minus a over 2. But this also can be written as x equals p over 2 minus a over 2. So either of these are acceptable answers. So that concludes your test review. Please make sure you have this completed for class.